tilted photographs. What are tilted photographs? So with tilted photographs, you don't intentionally tilt them, and the tilt angle should be between 0 and 3 degrees. Is that okay? Simple definition of tilted photographs. So you don't go intentionally tilting the photograph and then you say, now I have a tilted photograph. It has to be unintentionally tilted, unintentionally, right? So all things being equal, you may not have the axis of the camera coinciding with the vertical. And so that is where we talk about tilted photographs. Okay. Now, so this is the geometry of a tilted photograph. The geometry of a tilted photograph is such that you have the exposure station at the apex of some sort of pyramid. Are you okay? So that is it over there. That is the exposure station L. Okay. And the exposure station goes all the way. Of course, it drops a vertical, which is this one. Okay. Which doesn't go through the center of the photograph. So the line going through the center of the photograph is the principal line. All things being equal, that's a principal line. Of course, on the photograph, you have the principal line. We will talk about that. All right. And then we have the line going all the way through this to be the optical axis. Okay. All right. Now, where the vertical meets the photograph is called the nadir point, N. Are you okay? Nadir point. All right. So now we have two lines, the optical axis and then the vertical here. It forms a plane. So the plane between the vertical and then the principal line is called the principal plane. Okay. All right. Now, when we extend it all the way to the ground, so we define the ground with this box. Are you okay? All right. So it's assuming we're cutting a portion of the ground. All right. And we can now look at the projection, the projection of the nadir point on the ground. That's NG. Okay. Then we have the projection of the principal point on the ground. That's PG. And the projection of the principal point on the datum is PD. Same way we have ND. So these are projections of the nadir point and the principal point. So the principal point is actually the center of the photograph up here. Okay, where I'm rotating about somewhere there. Then the nadir point is this one. Again, that is the N. You see the N intersection of the vertical, which is being dropped from the exposure station, with the focal plane, if you like. Okay, photograph. Focal plane. The focal plane is tilted. If you've tilted a camera, then obviously your focal plane is also tilted. Okay, it's not vertical. All right, so principal plane, we know what it is. Optical axis, we know what it is. Principal line contains the nadir point and then the optical center. No, not the optical center. The principal point, okay. So if when you draw a line between the nadir point and the center of the photograph, you will get the principal line. All right. So the principal line actually moves like this. Okay. The center of the nadir point, the distance, the line joining the nadir point and the optical point is the iso center, which we'll look at very soon. Okay. Now we can talk about the tilt system. Are you okay? The angle system. We can have the Church angles, okay, which are omega, T, and S. So omega is the azimuth, T is the tilt. So you can see the azimuth down here. That's the azimuth, okay? So you can see that we are rendering it, the principal line, an angle of tilt between the principal line and the north. That is the azimuth. Then we have the tilt. The tilt is as a result of the vertical not coinciding with the optical axis. It's not coinciding. So what's the result? Because it's dropped, it's gone somewhere, it's gone a particular direction. So this angle here that I've just indicated, that is the T, that is T, is okay. So we can take that triangle, okay, and draw it like so. Can draw this triangle like this and exaggerate it. So this is what we are going to do. We're going to draw this and then we're going to pull this triangle out and exaggerate. All right. All right, so when we exaggerate and go closer, we see that L is there, N is here, intersection between the vertical, so that's the vertical camera axis. There you go. And camera lens. Isocenter is the center, you know, the bisector of the principal line as it joins the nadir points and the principal center. Okay, to be able to appreciate a coordinate system, to be able to appreciate coordinates for the tilted photograph, you need what we call an auxiliary system, an auxiliary coordinate system. All right. So in the auxiliary coordinate system, the auxiliary coordinate system is required. Okay, it's very important. I'm just repeating myself. There are two forms of the transformation. We have the rotation, then we have the translation. Okay, so rotation and then translation. Then we have a shift. Is that okay? I think we don't really talk about a shift here. All right, so there it is. When we look at this diagram, you can see that we can start with a shift. The shift is from here to here. It's like as if we want to treat the vertical, the tilted photograph as if it is what? A vertical photograph. So this is a planimetric view of the 3D. Okay. All right. Now, but don't forget that the triangle that we pulled out exists around this area. It exists here. Okay. All right. So if you go back to the diagram, so F, okay, let me go back to my drawing board. So F is this distance here. the focal length. T is a tilt. So the distance from here to here, which is actually N and P, are you okay? Is given by opposite over adjacent, which is tan. So tan T is equal to opposite, the distance MP, divided by F. So F tan T is the distance F MP. Is that okay? F tan T. So if you take the F, if you cross it over, I mean this JS stuff, you get F tan T equal to MP. So in this diagram, the reason we have F tan T is because of that. Now for a point A, it has like 3 set of coordinates of like 2 set of coordinates. Right, we can look at one in which the coordinate system hasn't been rotated. So we call that y prime, x prime. Okay, so if you look at the ends of the, you will see that, let me get my light. We have y prime, x prime. So x prime is here. Okay, and then we have s prime, y prime. Then so we do a shift of the s prime, y prime coordinate system to s prime prime, y prime prime. Then we rotate it. Then we get sy. So you get it. So I wish I could just, okay, let me just use this arrow to explain to you. We shift this to this point. Then we now have like this. We now be here. The thing is tilted, so it's caused a shift. Now, what we want is this. We want this. Are you okay? So we do a shift, then we do a rotation of theta. Are you okay? The rotation of theta. Okay, so rotation angle theta is S. So the swing. Remember we talk about swing, tilt, azimuth. Let's go back and look at the tilt from the bigger diagram and the swing. Swing is S. So I think I didn't really touch on that. S is this angle. Oh, why is this? Okay, let me move it. Okay, so so from Y all the way, this is S, is the swing. Are you okay? Swing angle. All right, so we are saying that theta and swing have a certain relationship. Are you okay? That we can actually talk about. Theta is S minus 180. All right. I mean, I think I'm feeling hungry. All of a sudden, I can't see the relationship, but that is true. Trust me. All right. So we can do this. S theta. So if you look at theta and an S, you can literally relate them. All right, great. Now the rotation to S prime prime, remember that we move from S prime to S prime prime to X. Okay. All right. So going back. So we move like this, X prime, we go to S prime prime, but we would by shift. Are you okay? Then to X. So it more or less Y prime to Y prime prime to Y. This is a photo coordinate system. This here is a photo coordinate system. All right. Here we haven't shifted. Here we have rotated. Okay. Here we haven't shifted. Here we have rotated. Okay, and then we are there. Once we rotate, then we get here. All right, so that's how the coordinate is. All right, so the relationship between the coordinates, if you look at it, I'm going back to my PDF, you see that the photo coordinate system has to be first rotated to x prime prime y prime, which is what you are looking at on the board. So this relationship is for coordinate transformation. Rotation aspect, most of the time, this is how it looks like. S cos theta minus y sine theta gives you x, y prime prime is x. So both of them has x, the y, just the trig functions that are a bit different. It's like cos sine, sine cos. Then you put a negative, you can remember it. All right. This explanation of f tan t, okay, which is actually the shift. All right, so finally, we can combine all of them to in such a way that we have the rotation and then we have the shift. So there'll be no shift in the y, in the x, but there'll be a shift in the y. Okay, so the shift is applied to only the y coordinate. Is that okay? All right. So basically, that is that. In trigonometry, sine theta is minus sine s if theta is equal to s minus 180, like as we saw, or 180 minus s, because s is more than 180 in that case. Because theta is minus cos s. We need to know these kind of relationships. I mean, it's mathematics dealing with here. So this is kind of a proof. So we can have a relationship between the different coordinate systems by the auxiliary coordinate system, and we don't mix them up. Are you okay? So theta equals 180 minus s means, so you can write the whole equation using s. You can write the equation using theta. Okay, so here the equation is made up of s, and then here we are using theta. All right, and then the rest is just put in the, you can actually find the scale of a tilted photograph by this formula. So here, merely you see the formula, you know what T is the tilt, F is the focal length, H flying height, small h is the height of a particular point. So here, every point has its own scale. Okay, so take note of that. Sec is 1 over cos. Cosec is 1 over sine. You know, like we need to know some of these things. The sine and the cosine. These things are maths. You're learning things in maths that you need to be applying. Are you okay? So that is it. So pause for a minute. Trying to be in a Zoom meeting, but that's okay. So we are in Accra, so we all have to be sharp. So here we go. We have the equation for the scale of a photograph. So here's another generic equation that you need to adapt. So you just go like this. If I go back and share my whiteboard. Okay, if you have this formula. What are we saying? What we're saying is this, that you can put capital A here. You can put capital A here for an object A whose height is A above D2. So the diagram that was shown, I mean, if you go looking at it, flying height is always like this. You leave it like as it is. Tilt angle, then this becomes small a. This is small a. Okay, so the y coordinate and this small y coordinate, how do we obtain this? Are you okay? Given set of photo coordinates, you're able to convert it using the auxiliary coordinate system. Okay, so you should always remember the auxiliary coordinate system, have it in your head. So here you can see we are converting x prime to x. Okay, so it's more or less x a prime y a prime. I get that, x a prime y a prime. So you replace all the x primes with x subscript a. So photogrammetry, the subscript is only saying a particular thing, particular object with that label. Are you okay? All right, so basically that's that. There's an example is also done. I think we work out an example, but you can also do ground coordinates the same way we did for the other one. So, but in this case, you can see the formulas are quite, you know, they are not as simple as the other one. I mean, this is not even the most complex formula in maths, but we can do this. Okay, you always work out the ground coordinates relative to the flight axis, and it's always a proportion of the ground. It's like as if you are working, you know, I mean, this looks more like working out a scale, like applying the scale to the photo coordinates. But in this case, you're making use of the x prime. Are you okay? All right. So except for the y coordinates is a bit of it. It's introduced even cos t to it. It has to be proven. This can be proven, but you're not being asked to prove. You're supposed to just get a final formula and understand how to apply it. Like lecturer should have told us this, we wouldn't have struggled much. So look at the example. You're only giving the values. The only thing that most of you don't know how to do is to use the calculator to put in the values. Okay. Apart from that, if you remember your formula and you have these values, I mean, what a computer skill. You need a formula for the scale, then you put in the values. Okay, but how do you put in 3 degrees, 27 degrees? I think that is where a lot of people have a problem. So on your calculator, there's a DMS somewhere on the calculator. There's a button. You press it to put in. You put in the degree. You press it. Put in the minute. You press it. Give 1 second to you put that. And you press it. Then you can now use the. Okay. You can use it. You can go online, and then you see. You know, there's this one that I'm using now. I'll see if I can show you an image of how it actually the DMS looks like. It's not looking too clear, but I'll see if I can show it to you. So it's like I said, all you need to put in your head is that the scale is f sec t y prime sine t, and then know the relationship between y prime and x. Okay, because this is coordinate transformation in disguise. When you talk about tilted photographs, we start learning. This is where we start learning coordinate transformation. We move from we do a shift and a rotation to get to the final thingy. All right. So if I'm to move this out, I just want to show you exactly how this. You look at this. DMS is there. Yeah. DMS is this one here. Okay. So you punch 45, you press it, 60, you press it. Then it will be going as minutes, degrees, minutes, seconds. Then you can also convert from degrees to degrees, minutes, seconds. Everybody who is hearing the sound of my voice should know how to do this. And if you don't, then you are doomed academically, not in the real life. Academically, it's going to be a big pain to your progress, as every surveyor needs to appreciate these things: degrees, minutes, seconds. All right. So I think he's been explaining it, isn't it? Let me see. Sexagesimal numbers. I don't know. I think that's what he means by that. Enter and display degrees, minutes, seconds. I think that's probably the proper term for it. Sorry, excuse me for my ignorance. So that is basically it. Okay. If you want to work this example out, like I said, given the following known values, x, a, y, so these are photo coordinates, but in the formula for scale, there is no photo coordinates. That means you need to convert these things to the y prime. Okay. So you need to go study the equation. So the equation to put in your head is actually this one. This is one of the most important equations that you need to know. Okay, this one here, then this one. So we've been given xa, ya, we can get sa prime, okay, ya prime, okay, and we know our f, you know the t. Now, are we using s or are we using theta? The formula will change slightly based on which one, the one that we want to go for. Okay, so we use theta. The signs change a bit. So here we have positive, positive. Here we have negative, positive. Negative, positive, negative, negative. Again, that's not the same. They are not the same. So if you miss the signs, that's it. Your answers are going to be wrong. But if your approach is correct, maybe you can give me some 2 marks and you'll be fine. All right. So it's P. This one, and I understand why some calculations are not done. In secondary school, I mean, you have to work everything out. But if you cannot substitute values like this into the formula, one, your problem is you have 2 problems, possible problems. Either you don't understand the formula, you don't know the formula, that's the first one, or you know the formula, but you just don't understand where to put it. Okay, so keep a few formulas as you go into write an exam like this. You need to keep a few formulas. So tilted photographs, there are more calculations, but I just want you to know this one, the scale. If you can do scale, calculate scale. Yeah, basically convert from one system to the other. I'm not even saying it's coming next exam. Nobody tells. A lot of students say, tell us what is coming. I don't even know where that's from. You know, the only way you know what is coming from is look at the past questions. Anyway, so scale on a tilted photograph. I think we just work one out. If you don't know how to work out the RF scale, that's another big problem. You need to see your friend to help you. Don't wait till you are embarrassed on national television. Go learn how to work out the representative fraction scale. Okay. So coordinates, I think the formula is also there. So we are ending on this one. Like I said, we have 2 more topics: project planning, rectification. Okay, these are 2 important topics. If you make time during the weekend, we cover a lot. That'll be good. Your assignment, I'm dropping some photographs on your WhatsApp page, and I want you to look at it. Is that okay?